Graphing quadratic functions. In a linear function, the highest power of the variable is 1. These are linear functions. They graph as a line. The functions on the left are quadratic functions. The highest power is 2. They graph as a curve called a parabola. This is a parabola. The vertex is the place where the parabola changes direction. When it is at the bottom, it is called a minimum. When it is at the top, it is called a maximum. These are the x-intercepts, where it crosses the x-axis. This is the y-intercept, where it crosses the y-axis. This parabola has no x-intercepts. This parabola has one x-intercept. The first parabola we will graph is called the parent function. All parabolas have the same shape as this one. They might be stretched or moved, but they all have the same basic shape. This function is y equals x squared. Begin with any number for x, for instance 0. 0 squared is 0, so the first point is 0, 0. This is the vertex. 1 squared is 1. This point would be 1, 1. Negative 1 squared is also positive 1, so the next point is negative 1, 1. 2 squared is 4, so this point is 2, 4. The next point is negative 2 squared, which is also positive 4. Negative 2, 4 will be our next point. 3 squared is 9 for the point 3, 9. Negative 3 squared is also positive 9 for the point negative 3, 9. Because the function is y equals x squared, the curve continues getting longer like this forever, controlled by the perfect square numbers. It is symmetrical with the same exact number on each side of a middle line. For every point on one side, there will be a same point in equal distance on the other side. The vertex is 0, 0. The center line, called the axis of symmetry, is x equals 0. The vertex in this case is a minimum at y equals 0. The x-intercepts and the y-intercept in this case are the same point, 0, 0. Domain and range are new words for you. The domain is the values that the x can be. Since the parabola goes on forever, the domain is all real numbers, written with a capital R with 2 lines. The range is the values that the y can be. That is all the numbers bigger than 0, since the parabola goes up from 0. Notice that every parabola will be controlled by square numbers. The pattern you need to memorize is the list of square numbers. First we went up 1, then 4, then 9, then 16, and so on. These are the perfect square numbers. As you work with parabolas, you will need to memorize this list: 1, 4, 9, 16, 25, 36, 49, and so on. To graph other parabolas in standard form, you must follow this list of steps. First you find A, B, and C. Then use this formula to find the axis of symmetry. Plug in the axis of symmetry to find the vertex, and finally find the y-intercept and other points. Let's look at an example. In this example, A is 2. It is the coefficient of x squared. B is the coefficient of x, negative 12, and C is the constant. Filling in this formula, we get negative 12 over 2 times 2. Negative is positive, so we get 12 over 4. The axis of symmetry then is x equals 3. Draw a dotted line at x equals 3. To find the vertex, plug in the value x equals 3 into the function. Y equals 2 times 3 squared minus 12 times 3 plus 10. Don't forget PEMDAS. 2 times 9 minus 36 plus 10, which is 18 minus 36 plus 10 equals negative 8. So the vertex is 3, negative 8. Now to find the y-intercept. The y-intercept is always 0, c. So in this case it's going to be 0, 10. The reason for this is because when we fill in 0 for x, we get y equals 2 times 0 squared minus 12 times 0 plus 10, leaving just 10. Fill in the y-intercept and a symmetrical point the same distance away on the other side. To find more points, we're going to use a table. Start with the vertex. Fill in numbers close to the vertex. Y equals 2 times 4 squared minus 12x plus 10, 32 minus 48 plus 10. Be careful of PEMDAS. Going the other way, the values should be the same since the parabola should be symmetrical. Graph the points. Notice that there's a pattern to the points that we have graphed. The distance 1 away from the vertex, we go up 2 times 1 squared. For the distance 2 away from the vertex, we go up 2 times 2 squared. The 2 comes from the a value. The squared numbers comes from the list of squared numbers we talked about earlier. When we go 3 away from the vertex, we go up 2 times 3 squared, or 18. From now on, we'll use this pattern when looking for more points in a parabola. Let's practice with this example. In this case, a equals 1, b equals 6, c equals 7. Fill in the formula with negative 6 over 2 times 1 for a negative 3. The axis of symmetry is x equals negative 3. Draw a dotted line at x equals negative 3. The vertex will begin with negative 3. Plug in the value negative 3 into the function. The vertex is negative 3, negative 2. The y-intercept will always be 0, c. c is 7, so 0, 7. Graph 0, 7 and a symmetrical point. Use the pattern that we learned to find other points. A is 1, so 1 times 1 is 1. When we go 1 over, we go 1 up. 1 times 4 is 4. So 2 over, we go up 4. 1 times 9 is 9. When we go 3 over, we go up 9, which we already did. 1 times 16 is 16. When we go 4 over, we go up 16, which is off the graph. Draw a smooth curve to connect the dots. The parabola faces up, so it has a minimum. The minimum is given by the y value of the vertex. Y equals negative 2. The domain is always all real numbers. This is the values x can take. The range is the values y can take. Since y goes up from negative 2, its y is greater than or equal to negative 2. Here is another example. In this example, a is negative 2, b is negative 4, c is positive 6. Fill in the formula negative 4 over 2 times negative 2 becomes positive 4 over negative 4 for negative 1. The axis of symmetry is x equals negative 1. Draw a dotted line at x equals negative 1. The vertex will start with negative 1. Plug in the value negative 1 into the function. The vertex then is negative 1, 8. When a is negative, the parabola is going to open downwards like this, and the vertex will be a maximum with the same value as the y of the vertex, so y equals 8. The y-intercept will be 0, c as usual. Maximum is y equals 8, the y value of the vertex. The domain is always all real numbers. The range now goes down, so its y is less than or equal to 8. To find our other values, remember that a is negative 2, so negative 2 times 1 is negative 2. We go over 1 and down 2 for the first points. Negative 2 times 4 equals negative 8. Go over 2 and down 8. The next set of points will be negative 2 times 9 for negative 18. Go over 3 and down 18, which is off the graph. Draw a smooth curve to connect the dots. Now that you've had a few examples, pause the video here and try the next one yourself. Now that you have tried it yourself, check your work. A is negative, so this parabola will open downwards. It will have a maximum. A is negative 1, B is negative 4, C is negative 7. The axis of symmetry is x equals negative 2. Draw a dotted line at x equals negative 2. Plug in negative 2 to find the vertex. The vertex is negative 2, negative 3. The y-intercept is 0, negative 7. The maximum is at y equals negative 3. The domain is all real numbers. The range is y is less than or equal to negative 3. Find the rest of the points. Multiply a, which is negative 1, times 1, 4, 9, 16, and so on. Draw a smooth curve and you are done. Now pause the video and try the next one yourself. Now that you have tried it, check your work. This time a is negative 1/2, b is 2, and c is 1. Negative b over 2a is negative 2 over 2 times negative 1/2. This will be negative 2 over negative 1, which is a positive 2. The axis of symmetry is x equals 2. Use x equals 2 to calculate the vertex. A was negative, so this parabola will open downwards. It will have a maximum at y equals 3, and the range will be y is less than or equal to 3. The domain, as always, is all real numbers. The y-intercept is 0, c, which is 1. Calculate the other points as we have done before by multiplying a times the list of square numbers. Negative 1/2 times 1 equals negative 1/2. Negative 1/2 times 4 is negative 2. Go over 2 and down 2. Negative 1/2 times 9 is negative 4.5. Go over 3 and down 4.5. Negative 1/2 times 16 is negative 8. Go over 4 and down 8. Negative 1/2 times 25 is negative 12.5. Go over 5 and down 12.5. Draw a smooth curve. In this example, the x term is missing. Replace it with a 0 for x squared plus 0x plus 3. So a is 1, b is 0, and c is 3. Now pause the video and try it yourself. Now that you have tried it yourself, check your work. The axis of symmetry is x equals 0. The vertex is 0, 3. So the y-intercept is the same as the vertex, 0, 3. It is a minimum, y equals 3. The domain is all real numbers, and the range is y is greater than or equal to 3. To find the other points, a times 1 squared equals 1. A times 4 equals 4. A times 9 equals 9. Connect the dots with a smooth curve. In this example, the constant is missing. Replace it with a 0. A equals negative 3, b equals 12, c equals 0. Now pause the video and try it yourself. Now that you have tried it, check your work. The axis of symmetry is x equals 2. The vertex is 2, 12. The parabola has a maximum at y equals 12. The y-intercept is 0, 0. The domain is all real numbers. The range is y is less than or equal to 12. Using negative 3 times the list of square numbers, find the other points. Negative 3 times 1, negative 3 times 4 is negative 12, which we already have. All the rest are off the graph. Connect the dots with a smooth curve. Please continue to review these notes as you complete your homework.